Hello viewers, I want to do a very quick video on factorization of algebraic expressions. As you can see on the screen, uh, the term factorization means writing the given expression as a product of its factors. And these factors can be numbers, variables, or an algebraic expression. So factorization is very elementary, very basic, but you need to be very familiar with the different forms of factorization. When you are given an expression to factorize, what you are simply asked to do is to break that expression into two factors that when you multiply those factors together, you get the original number. We're going to use some examples to demonstrate this. Let's take note that a factor of a number or an expression, as you can see, is something that can divide that number or that expression without a remainder. For example, the factors of 55, you're going to have 1 times 55, 5 times 11. If you multiply these two, you will get 55. You multiply 5 times 11, you will get 55. What about something like 6? Factors of 6, 2 times 3. Now in this case, you are given not just one number, but a number and a variable, and another number and a variable, and then you are asked to factorize. So you want to look for the factors that can satisfy these two. So in that case, I want to see what is common to both 9a and 3a. Remember, what is common to them will divide both numbers without a remainder. So what's the common thing between 9 and 3? I know that 3 times 3 will give me 9. So 3 is common to both 3 and 9. And what is common to a and a here? That's a. So now that I have picked out the highest common factor to both expressions, what I will do is this 9a so watch what I'm doing. I know that this 3a is common to both 9a and 3a. So I am actually using 3a to divide 9a and to divide 3a, and I am not expected to get a remainder. So if I use 9a to divide 3a, when this 3 divides 9, what will remain is 3. And then when this a divides this a, it goes. This 3 will divide this 3, it will go. A will divide A, and both of them will go. So what's remaining is the 3a outside the bracket. Here I have 3, the a is gone, plus here everything is gone, and what is remaining is just 1. So that is the factorization of this expression. But in most cases, you need to really master this technique so that when you are given something like 9a plus 3a, you quickly pick out the highest common factor of both of them and you say 3a. 3a goes into 9a, or rather 3 goes into 9. What you have left is 3. A goes into a, that will go away. 3 go into this 3, what that gives us 1, and a goes into a, the a goes. So that's how you are expected to master it, so that when you're working, you're fast about it. We have another example here. I have 6x squared and I have 3x. What is common to both 6 and 3? What is common is 3. What is common to x squared and x? X is common to both x squared and x. So I'll open my brackets. Now, when 3x divides 6x, what will be remaining there is just 2x. Yes, when 3 divides 6, you get 2. When x divides x squared, you get x. And when 3x divides 3x, when this 3x divides 3x, what is left is 1. Simple. Let's look at this expression. I have 6x squared minus 3x plus 4x minus 2. What I can do is to group them into two different expressions. Sometimes I may need to rearrange, but in this case, they have been arranged for me in the expression. So between 6x squared minus 3x, what is common there is 3x. And just like we did in the example above, when 3x goes into 6x squared, you get 2x, minus when 3x goes into 3x, 1. Now, for this other expression, what is common between 4x and 2? That's actually 2 that is common. And when 2 goes into 4x, you get 2x. 2 goes into 2, you get 1. So now that I have this, look at, you can notice that 2x minus 1 in this bracket is the same as 2x minus 1 in this bracket. So my answer will be 2x minus 1, which is common, times, you now bring what is outside the bracket, 3x plus 2. Now the beauty about factorization is that when you multiply the factors together, you will get the original expression. Here in this case, when you multiply these factors, you will get this original expression. Hello guys, let's factorize 3x plus 15. What is common between these two expressions, 3x and 15? What is common is 3. X is not common, but 3 is common to both 3 and 15. So we'll bring out the 3. Now, when 3 divides 3x, what you will get there is x. And when 3 divides 15, you'll get 3. So that's it. That's the factorization. Let's take the second to the last. Here I have 25p squared minus 10p. What is common to this expression and this expression? I think 5 is common to both 25 and 10. So I'll bring out 5. P is common to p squared and p. So I'll bring out p. Then I'll open my bracket. When 5 divides 25, there I'll get 5. When p divides p squared, something like this, p squared over p, this p will go and then this one will go. So what will remain is 1p. Now there's a minus sign in between them. When 5 divides 10, I'll get 2. And when p divides p, that p will go. So that's it. The answer is 5p into 5p minus 2. All right, we'll have the last one here. What is common between 4p cubed and 12p? 4 is common to these two expressions. So I'll bring out 4. P is also common. I'll bring out p and then I'll open the bracket. 4p into 4p cubed, I'll have p squared. Please don't get confused. This is p cubed divided by p. This p will go, and when it will knock off 1p from here, so what will remain is 2p squared. All right, we'll now come to the second expression. When 4 divides 12, I'll get 3. And when p divides p, That's it. Just the p is knocked off. So the answer is 4p into p squared minus 3. I hope with these few examples, we've been able to introduce ourselves into the concept of factorization. In the next video, we're going to do factorization of what is called a perfect square. Please watch out for the next video. Kindly comment and share this video. Thanks and bye for now.